Okay, here we go. So today, we talk about solving radical equations. Radical equation is the equation that has a variable in the radicand or has a variable with a rational exponent. These examples. These are examples of what a radical equation looks like. Okay? I'm not solving here. I'm just saying this is what a radical equation looks like. Where the variable is in the radicand or it's being raised to a rational exponent. This is not an example of a radical equation because the variable is not in the radicand. Okay? So these are examples of radical equations. This is not a radical equation. Yeah, this equation has a radical in it, but it's not a radical equation. Okay? Does that seem simple enough? How to identify them?
Yes.
Okay. I want to point out, in case one of you is looking at examples in your book, on page 386, at the top of the page, there's an error in the book. It says you can solve the equation of the form x to the n over m. It should say x to the m over n to match up with the rest of that statement. Does that make sense? If you follow along the rest of that statement, it doesn't make sense the way they had that written. So there's just an error there. Not that you have to go back and look at it. I'm just saying if you are looking at that and all of a sudden you're saying, wait a minute, that doesn't make sense.
So the first one, you put n over m?
The first one should be m over n. Mary over Nancy. Is that the way it is?
Yeah, I have that.
Oh, okay, my book does not.
Like,
That one says n over n. Oh, the second one, yeah. But the first one
oh,
should say
okay.
m over n.
Oh, God.
Where it says you can solve equations of the form x to the m over n is what it should say equals k.
Yeah, my book says that.
Okay, good. So just my book is messed up. So moving on. Here's some examples to solve. The key to solving these is to get the radical all by itself. So step one, I go really slow.
I can't see.
Right's okay. Get the radical
Try too hard.
by itself. Okay? Get the radical by itself. So in example one here, what's in the way of having the radical all by itself? Louder? Negative 6. So how do I undo minus 6? Add 6. So I get the square root of 5x plus 1 equals 6. Add 6 to both sides. Okay? Step 2. Undo the radical. So how do we undo a square root? We square. So we undo a square root by squaring both sides. And so we get the square root and the square cancel. So we get everything underneath. 5x plus 1 is equal to 36. mean, we could probably write a whole bunch of steps here, but I'm just gonna say, step 3, finish solving, because now you should have something that looks like algebra 1.
Can we just put solve for x for number 3?
Sure. Whatever you wanna write there, you don't even have to put it if you don't want to. At this point, the radical's gone, we're gonna finish, we subtract 1 from both sides, 5x equals 35, divide by 5, x equals 7. Okay? So just some simple little steps there to give you some guidance in case you get stuck on the next quiz or on your test. You can look back at that. Okay? So x equals 7. That's what I got. What did we get? 7. Yay! We win. Okay? Number 2. Liz, you're so hyper there. What do you think we should do first?
I'm not hyper.
Bouncing around.
You did, would you dog it? What? What? I don't know,
Is that off
you
the
said
side?
just,
Liz, what do I do first?
do you do the 3 halves first or distribute the 2?
Ah, good question. Can I distribute the 2 here? Let me ask you this. If I had this equation, can I distribute that 2? I can't. Remember order of operations?
Yes.
Exponents, parentheses, exponents, multiply, divide. So I have to do exponents first. So like, it's not okay in math to do that. Right? Not okay. So let's just wipe that thought right off from my board.
Wipe it off.
Wiped off. So going back to the original statement here, what's step 1 say?
Get the radical, so divide by 2.
Okay, get the radical by itself. So hopefully you're recognizing because of that fractional exponent, meaning that rational exponent, that is my radical. This could be rewritten as the square root of this cubed, right? That's what we practiced yesterday. I'm not going to do it, I will, but I'm going to erase it. The square root, the denominator is the index, x plus 3, and we could do this if we wanted to, cubed. Okay, if I want, I can rewrite it that way. If that makes more sense for you, you can rewrite it that way. I'm not going to, but you can. So the first thing we're going to do is divide by 2 to get rid of this. And so we get x plus 3 to the 3 halves equals 27. Okay? What's step 2 say? Can't see it on my board. Undo the radical. What's a radical? 3 halves, right? How do you undo 3 halves?
What are the reciprocal?
Yeah, we think of it as multiplying, but we're not really multiplying here. We're going to raise it to the reciprocal. The reciprocal of 3 halves is 2/3. I said we think of it as undoing multiplying because that's what you would do now. You'd multiply this. 3 over 2 times 2 over 3, these would cancel. I get a 1. X plus 3 to the 1. And since I don't have, or since my exponent's a 1, I don't need the parentheses anymore. I don't need to put the 1 there.
You wouldn't distribute, you wouldn't put the 2/3 to the x.
No, you can't do that. Just like we couldn't do this. Remember this? It's not equal to x squared plus 1 squared, is it? Remember we had a long conversation about that. You square a binomial, you have to get 3 terms. So it's not okay in math to go ahead and think of this as distributing that power because of the plus sign. Now if I had x times 3 squared, now I could distribute x squared, 3 squared. That's correct. But not when there's a plus sign in there. Okay, these are great questions leading to awesome discussion, so thank you for asking those questions. So, this is what I do. If everything works out good, you probably throw it in your calculator, but I always do the root first. And I think of this as the cube root of 27. Okay?
Oh, we could do that, we don't have to.
Yep, you can split that up because 1/3 times 2 is still 2/3, right? So if I split it up like I did here, I can deal with the root first and then deal with the power. What's the cube root of 27? 3, right? What times itself is 27. Well, 3 times 3 is 9, times 3 is 27. So the cube root of 27 is 3. And what's 3 squared? So x plus 3 equals 9. So x is equal to 6. Okay? See if we're the winner again. Winner, winner, chicken dinner! Yeah. Did you? Did you watch that movie?
What's the movie?
21, they said that all the time in 21, didn't they?
What's 21?
You never seen the movie 21?
I feel like I have this about one.
It's, you haven't seen it either?
No, I just knew it was Guy Fieri on Diners, Drive-Ins, and Dives says that, so.
Extraneous solutions are solutions that don't work even though you made no mistakes. Probably Webster's dictionary doesn't have this in there for the definition of extraneous solutions. But you can do everything right, and sometimes they just don't work. Those are called extraneous solutions. So when you're solving these today, you have to check your work. Okay? You have to check your work because you can do everything right, you can get a nice number, you can think, oh, that's awesome, it worked out great, and it doesn't work. Alrighty, pause, Lee. So, let's do this example right here. What do you think we should do? What's step 1? Janelle, what's step 1? Get the radical by itself. What's in the way of having the radical by itself? The plus 3. So you want to subtract 3 from both sides. So we have an x minus 3 over there, right? Okay. Now, what's step 2? Undo the radical. So how do you undo the radical?
Square.
Square both sides. So my radical and my square cancel. I get 5x minus 1.
Whoops.
What do I get on the other side when I square that? I do not get x squared minus 9. Remember, we just showed that on the previous slide. You can't just square them. You have to get 3 terms. It's x minus 3 times x minus 3. If you don't remember how to do the shortcut, you'd have to FOIL it. Who remembers the shortcut? What's the first term going to be? X squared. What's the last term going to be? What? 9. And it always has to be a plus. And the middle term is the first times the second times 2. So what's x times negative 3? Negative 3x times 2. Negative 6x. Okay? Now this is not at all what the others look like, is it? So a little more work involved, but what's step 3 say?
Solve for X.
Finish solving for x, which means now I have a quadratic, and so to solve a quadratic, we have to set it equal to 0. So I have to move my 5x and my 1 over. When I move my 5x over, I subtract 5x. What's negative 6x minus 5x? Let me do
Negative
this.
11.
It's negative 11x. And then if I add 1 to both sides, I get plus 10. So now I'm ready to solve my quadratic. How many different ways did we learn to solve quadratics? Multiple. Good word when you don't know the number.
How did you get 6x?
It's the first times the second times 2. The shortcut to FOILing, when you're squaring a binomial, you square the first term, you square the second term, but to get the middle term, it's the first times the second times 2. Okay? What we're saying is O and I in FOIL are going to give me two numbers that are the same. In this case, they're both negative 3x. So negative 3x and negative 3x is negative 6x. Yeah.
And one thing, until I sort of got it in my head that I used to do, or probably still do, is even off to the side, just write it out exactly as it is. The quantity x minus 3 times the quantity x minus 3. And then that's in a form that's really familiar. So then I could just chunk through it and see, you know, the shortcut's nice. But if you forget the shortcut, you can always write it out the long way.
Right. And that's what I was saying. If you don't remember the shortcut, you'll have to take this over here and say x minus 3 times x minus 3, and you'll have to FOIL. And when you do O, you'll get minus 3x, and when you do I, you'll get minus 3x. Minus 3x minus 3x is minus 6x. Okay? All right, now let's get back to the original question. We learned multiple ways of solving quadratics. What's one method? Factoring. What's another method? Quadratic formula. And the third method? Graphing. Okay? Yeah, we didn't want to graph, right? So do we want to factor this or quadratic formula? Quadratic formula is x equals the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And if you don't know how to factor very well, you'll have to jump right into the quadratic formula. Okay? This one actually factors easily. And so we're going to factor this. The more factoring I do for you, the more it'll catch on for some of you. The only way to get x squared is x times x. What do we say if that sign, that second sign is a plus? What does that mean about my signs here? They have to be the same. They have to be the same as this sign. So they both have to be negative this time. And then we get down to the last two, and that comes from the factors of 10, which are 1 and 10, and 2 and 5. And then we go back to the signs. Because the signs are the same, we need the two that add up to 11. And they are 10 and 1. Or 1 and 10. So now you remember from here, we say this means x minus 10 equals 0, or x minus 1 equals 0. In this case, x equals 10. In this case, x equals 1. Kind of going quick through this. We spent weeks on this already, how to solve quadratics. So if you need some more help on that, and I'm going too fast, come see me. All right? Now we got two nice answers. Unfortunately, it's possible one or neither of them work. Okay? So we have to test it. I'm gonna erase this over here so I have a little room to test. And so we go back to the original. Square root of 5x minus 1 plus 3 equals x. So when x was 10, we get the square root of 5 times 10 minus 1 plus 3 equals 10. What's 5 times 10? 50. 50 minus 1 is 49. What's square root of 49? 7. 7 plus 3 is 10. That one worked, didn't it? So this one gives me a good number. Now let's go back and try 1. So 5 times 1 . What's 5 times 1? 5. 5 minus 1 is 4. Square root of 4 is 2 plus 3 is not equal to 1. Right? That one didn't work. So my only answer
It's 10.
is 10. It's the only one that works. Okay? Extraneous solutions. When you do everything right, it just still doesn't work out.
What if they're both wrong? How do you?
Then you'd say no solutions. Yep. If you you work it out, you get an answer and it doesn't work, or you work it out, you get 3 answers and none of them work, then there's no solution. It means there's no real numbers that will make that work out. Okay? This one looks a little different because there's what? 2 radicals. Okay? And so the rules change just a little bit when there's 2 radicals. You have to first try to get them on opposite sides. Well, in this case, that's going to be easy. Square root of 3x plus 2 equals square root of 2x plus 7. We just added this to both sides so it wasn't on the left side anymore. Okay? So what do we do now? We square. We undo the radical, so we square both sides. You see, as though it looked a little scary at first, because I only had 1 radical on each side, when I squared it, they both cancel. And so I'm left with 3x plus 2 equals 2x plus 7. So if I subtract 2x from both sides, I get x, and if I subtract 2 from both sides, I get 5. Nice and clean, no problem. Got a nice number. Probably not setting off any alarms, but it's possible that doesn't work. So we have to go back to the original. Square root of 3 times 5 plus 2 minus the square root of 2 times 5 plus 7, and ask, is that equal to 0? Well, what's 3 times 5? 15. 15 plus 2 is? So square root of 17. 2 times 5 is? 10 plus 7 is? 17. Is square root of 17 minus square root of 17 0? Yeah. So it works. So x is equal to 5. Okay, you cannot just say, oh, it works, I did everything right. Sometimes you'll do everything right and it just does not work. So you have to test it. Okay? We're just going to jump down to numbers 35 through 51,
All or
the odds. There's 9 problems there. So lesson 7.5, 35 through 51, odds. Okay, that's 9 problems. Some of them are going to take some time. I'm not because there's only 9. I'm not going to be real quick to just come over and show you how to do it. I might look at one of the even ones and show you how to do the even one, similar to it, to remind you. But work it out with your groups. Trying to communicate.